Multiplicity. And eventually we're going to bring all these ideas together and solve a couple problems here, and I'm going to eventually give you some to do that we're going to discuss in class, kind of showing calculator usage and all that stuff too. So, but here, we have this, most of the time you're not going to be given a polynomial function where it's factored for you. I mean, here it's factored, you have x plus 4 to the third power, x minus 2 to the second power, x minus 5. If you're able to do a factoring and you have factors where that are appearing more than once, that means that they're going to count as several factors. Like the x plus 4 is a factor. X plus 4 is going to count as chances are, if I were to multiply this all out, I would see that this is a 6-degree polynomial. And I would expect to have 6 different results, but that's not happening here. I actually only have 3 results because 2 of them have multiplicities other than 1. X equals negative 4 is going to have a multiplicity of 3 because there's 3 factors of x plus 4 going in there. But the thing is, how do I recognize that? Because as I said, we're not going to be having something that's in this factored form at all. It's going to usually be completely FOILed out. So how am I going to know about that? Well, I can tell that because here at negative 4, if I look right here, that graph flattens out a bit, passes through negative 4, and continues on through the graph. That's how I tell if I have an odd multiplicity other than 1. Okay? I see a flattening happening. Now, a flattening can also indicate a multiplicity of 5, a multiplicity of 7, so forth and so on. But as far as our discussion in this course, we're only going to go to as high as a multiplicity of 3. So keep that in mind. That's going to be a multiplicity of 3 for our purposes. But if you get to more advanced math, it could just be an odd multiplicity. And you have to determine how many times that particular root here, negative 4, is going to be counted as a root. At 2, I notice that the graph is actually tangent to the x-axis there. If I see tangency, whether it's on the top or bottom doesn't matter. If I see tangency where the graph touches that point, that x-intercept, that root, but doesn't pass through the x-axis and continues on, that indicates I have an even multiplicity. Now for our purposes here, it's 2. It could be any other even multiplicity like 4, 6, it count as that many, but for our purposes here, we're not going to go quite that high and sophisticated with it. So multiplicity of 2, which means that 2 would count as 2 separate roots, and of course 5 has a multiplicity of 1. The graph just passes through there. It doesn't do any flattening. It doesn't become tangent. So that would account for all basically 6 roots. Negative 4 counts as 3 of them, 2 would count as 2 of them, and 5 would count as the last one, therefore giving you a grand total of 6. So if I would see a 6-degree polynomial, and I only see 3 roots, so I'm not going to be looking for, because usually if I only see 3 real roots, I'd say, well, the other ones are not real, I have to find where they are, I have to go through and do more stuff, and I don't. It's just that I have some multiplicity sometimes, I have to keep aware of those.